Alright class, this is just more graphing with the rational functions, part 2. So we're going to do everything we did yesterday, simplify, then state vertical asymptote, holes, horizontal asymptote, domain, and range. I like to do the domain first, and then we have to graph it over on the side. So first off, if you set this piece equal to 0, first of all you can't factor that, so let's set it equal to 0 and see what we get. We get x squared equals -2, which will give you an imaginary solution, which means that there are no domain restrictions. So I'm going to say the domain is that x is all real numbers. Alright, next, because of that, a and b, none for a, none for b, for vertical asymptote or holes. Okay? Horizontal asymptotes, you look at the rules. If the denominator has a higher degree than the numerator, if it's bottom heavy, we say that y equals 0. Now we graph it and look at the graph. Alright, I have my graph entered in. I'm going to hit graph now and look at it. And sure enough, the x's all happen left to right, and then it looks like when you plug a 0 in for x, you get -3, so that looks like the lowest point it goes. You can also test it by looking at the minimum there. So this is the graph. 1, 2, 3. We have a horizontal asymptote at 0. So it kind of looks like that. Something like that. Okay? Now, range. Remember, range is where it exists. This is one where it only exists in a very short region here. The graph exists only in this y range. Remember, range is y. Think of it as like the height. So we would say y is greater than and equal to -3, but then it has to be less than 0. Because if it hits 0, then it doesn't cross or go to the asymptote, so it can't hit 0. But it gets really close, almost basically to 0. And that's the answer. So we did one of those yesterday. Let's look down here. First thing you should do is completely factor, so we can get our domain restrictions. Okay, so before you cancel anything, the first thing you do is state the domain restrictions. Right now, I see 3 things on the bottom, and remember, it's the opposite values, so x cannot equal -2, 2, or -1. Now, you have to decide which of those are holes or vertical asymptotes. Does anything cancel? Sure enough, when you simplify this, the x plus 1's go away, which means that for b, the hole, the x coordinate, or the thing from the domain that's the hole, is -1. Remember, you need to find the y coordinate. We'll do that next. First, we're going to figure out our vertical asymptotes. They're the things that are left over underneath from the domain. So we'd say the vertical asymptotes are x is equal to -2 and x is equal to 2. Next, we're going to find the y coordinate of the hole. So I'm going to do that, use the simplified version of the equation. So since it's -1, it's 3 times -1 squared over -1 plus 2, -1 minus 2. We get a 3 on top because -1 squared is positive. And then we get 1 times -3. So you get -1. We get a hole at -1, -1. Alright, next we need the horizontal asymptote. If you multiply these together, you get a 3x cubed. If you multiply this together, you get an x cubed. You just multiply to get it back to unfactored form, multiply the x's. It's rule number 2 because they're both the same, so it'll be 3 divided by 1, or y is equal to 3. Alright, let's start graphing this then. We know at -2 and 2 we have vertical asymptotes. We know at 3 we have a horizontal asymptote. We know we have a hole at -1, -1. Alright, let's see what this looks like. Let's graph it. Okay, I had just paused it so I can get this typed in. So make sure you guys pause the video if you want to type it in and follow me. Here's the equation typed in. Now I'm going to graph it, and that is what it looks like. I want to find this point just to make sure that's 0. I'm going to do a maximum here just to double check that point. Down here, it looks like it is 0, 0. And remember, that is calculator speak for 0, 0. E to the -7th and e to the -13th are 0.0000. So those are both 0, 0. Okay, so I'm going to graph this now on my paper. Basically what this looks like is a parabola down here that goes through this, but there's a hole right there, and then it comes down from the vertical asymptote and goes off to 3. Okay, so the range is a little weird here. We could either say where it exists or where it doesn't exist, but usually you only say where it doesn't exist if it's like a point. Since we're doing a range of values, you'd probably want to say where it exists. So the graph exists everywhere down here, including this hole. And that's because if you notice to the right of the hole, at this spot, -1 exists right here. There's part of the graph that exists right there. So even though there's a hole, the y-coordinate of the hole is -1, it doesn't matter in this example because there's another spot where the y of -1 exists. So the graph exists all down there, and it exists all up here. So we're going to have to write two inequalities here. We're going to say that the range is y such that y is greater than 3, and we're going to say y is less than or equal to 0. That is where the graph exists. Okay? Alright, so now on the back, all we're doing is stating horizontal asymptotes. We're looking at our rules. Now the second one is kind of the weird one that I wanted to talk about. First one, there's no x's on the the top. There's x cubed on the bottom. That follows rule 3. When it's bottom heavy, you just say it's y equals 0. Okay? This one here, ignore the 5 for now. It's a different, because the rules only apply to fractional algebraic fractions. So that +5 we'll deal with later. We have to figure out where the horizontal asymptote is with this piece here. Well, on top we have a 3x squared. On the bottom you have an x squared. They match. That means the rule is rule 2, where the denominator and numerator are the same. So you get y is equal to 3. However, that's only if we had this graph. Think about transformations again. When we had a +5 tacked onto the end of a quadratic or anything else, that shifts it up 5. So, really where the horizontal asymptote ends up is at y equals 8. Okay? So, and I'm going to talk about that in class from the worksheet anyway, from the answers from last night. And then finally, we have a 2x cubed on top and a 2500x squared. This one is top heavy. It's the first scenario. So we'd say that there is no horizontal asymptote. Okay, so that was just going through those rules one more time. And that is all.